Okay, let's talk microbial growth curve. So all microbes follow this basic pattern. The slope and the amount of the lines and the amount of time that these different phases take is going to be different for different types of microbes, but they all follow the same basic 4 steps. So this growth curve, this is how a new population or group of bacteria or other microbes grow once they're put into a new environment. So if you put a sample onto a new petri dish, they would follow this pattern. So first, number 1 here is the lag phase. So lag means to be slow or to fall behind. For a while, it doesn't really look like anything is happening. They're not doing any cell division yet. This is because the bacteria just entered or were put into a brand new environment. So it takes them some time to build up the nutrients or find and get the nutrients that they need. It may take them some time to repair any damage or injuries to their cells from being transferred or moving to a new environment. It takes them some time to adjust to the new conditions. After they've adjusted and they have all the different nutrients that they need, they've had a chance to repair any damage or problems to their cells, then they go into phase 2. This is called the log phase. It's called log like logarithmic, which means it's an exponential increase. So this line here is following the number of cells. So for a while, you have the same number of cells that you started with, that you put into that petri dish or into that new environment. There's no new ones showing up yet. Once the cells have adjusted, they start doing cell division. So you start to see more and more and more and more. So this is exponential, very rapid growth over time in the number of living bacterial cells. Eventually, they start to run low on space or resources, and that's when you get into this third phase called the stationary phase, where you have them staying at the same number. Now, they didn't stop doing cell division. They're still doing cell division, but some of the older cells are now dying off. So you have the same number dying as the new ones that are growing. So here it says rate of cell division, the new ones that are growing, and cell death are about equal. So you get a kind of a flat number. At this point, the population is really stable. Their metabolism slows down a little bit. They're not doing this just constant rapid cell division. So the bacterial metabolism slows down a bit here. Now, antibiotics, they're most effective in this stage here, the log phase. When cells are growing really rapidly, they're vulnerable to interference from different medications, which is why it's important to get a bacterial infection diagnosed early, and also to always take the antibiotics consistently until it's all the way done. Because if you have an infection or disease where the bacteria are getting into this phase and you take some antibiotics and it pushes that population down, you might think, oh, well, I'm starting to feel better, so I'll just quit taking the antibiotics early. Well, now you have a low number of cells, and they basically start this logarithmic phase all over again. So always take your antibiotics all the way through so it can kill off the cells at these low numbers. In the stationary phase, sometimes antibiotics are not as effective because that bacterial metabolism has slowed down. So again, it's always important to take the whole full course of antibiotics to get rid of them. Now, eventually, bacteria are usually stuck in their environment, whether it's inside a certain part of an animal or it's inside a test tube or a petri dish. So they eventually will run out of space. They'll eventually run out of different nutrients that they need, and they will eventually start to die. This is called the death or decline phase. This is when they don't have enough stuff. They don't have enough supplies to do cell division, so you just have cells dying off. And eventually this would go down to 0 if it did not have new access to other nutrients coming in. And those are the 4 phases.